Okay, hello and welcome to this NEP on Pythagoras' theorem, so notes, examples and practice questions. Now, we've got our title here, so wherever you're writing this in your folders or in your notepads or your notes books, get that title down and then we are going to do the notes. So the notes section says, in all right angled triangles, and that's really, really important, the three sides always have the same relationship. And then what we have is we have this formula here, a squared plus b squared equals c squared. So we've got three sides of the triangle, 1, 2, 3, and they are always in this relationship. Okay, now they're in right angled triangles, and a right angled triangle has something called a hypotenuse. And the hypotenuse is always labelled c, it is the longest side, and it is always opposite the right angle. So we're going to talk about that when we come to do our examples. And then this little blue box here says, which is really, really helpful, always label your sides first, start with the hypotenuse C, which is opposite the right angle. So in our examples, that's the first thing we're going to do. So we're going to move on to our examples and we'll refer back to the notes if we need them. So question 1 says, label the sides of this right angled triangle, A, B and C, and substitute into the formula to find x. Now what we said is always label your sides first, start with the hypotenuse. So the hypotenuse is the name of the side that is opposite the right angle. We're going to label that C. C is opposite the right angle and it's actually always the longest side. So it's always going to be the C that's on its own in our equation. Now, the other two sides actually don't matter too much. So I'm going to label them A and B like so, but it doesn't matter how you order those. And then what I'm going to do is I'm going to substitute into the formula. So A is 12. So instead of writing A, I'm going to write 12, and it's still squared. And the same for B, I'm going to write 16 squared. And then that equals c squared. So c is x, I don't know what that is, so that's x squared. And what we've got here is we have an equation with one unknown, so we are able to solve that by using the relationship we know between the sides. So the first thing I'm going to do is I'm going to work out the left-hand side. So 12 squared plus 16 squared, and you can just put all of that straight in your calculator, is 400. So literally just copy that into your calculator. You could, if you wanted, do it like this. Equals x squared, but you don't need to. It can all go in together. And then finally what you need to do is you need to square root to get your answer. So x equals 20 centimetres. And you know that's a sensible answer because it is the longest side. So it is longer than the other two, which it has to be the hypotenuse. Okay, moving on to question 2. So there's less structure this time. It says use Pythagoras' theorem to calculate x. But we're still going to do it in the exact same order. So I'm going to label C as opposite my right angle, and then A and B don't really matter. But I've still got this formula that I'm going to use every time for Pythagoras. And now I can sub in. So 4 squared plus 7 squared equals x squared. Then I can work out the left-hand side. I can do it like this, or straight in my calculator, it doesn't matter. So 65 equals x squared, and then to get x on its own, that equals 8.06225. So I've got lots of decimal places there, and then I'm going to round 1, 2, 3 significant figures. Gives me my answer. And again, that's sensible because it is longer than my other two sides. Okay, final example here. It says use Pythagoras' theorem to calculate x. So same question, and I'm going to do the same process. So I'm going to start by labelling. So I've got C, and then A and B don't really matter. Now what you might notice on this question is we're actually already given the hypotenuse. But as long as we label this consistently, it actually shouldn't make things much harder. And that's why the labelling is so important. If you forget to do the labelling, you're quite likely to make a mistake with this here. So now what I'm going to do is I'm going to sub in. This time I don't know what a is. So that's x squared. B is 7. And c is 12. So I can start to work out my numbers like this. Now the problem I've got is x squared isn't on its own this time. But I can apply my knowledge of solving equations to work out what x is. So I'm left with x squared equals 95. Then I can square root at the very end. And then again, 1, 2, 3, so equals 9.75. And that makes sense, because 12 has to be the longest side. Now a really, really common mistake is to see a right angle triangle, get really excited you know how to do Pythagoras, and do this. And then you solve it like so, just because you haven't labelled your sides or thought about the question. And then you get x equals 13.9. But x cannot equal 13.9 because this has to be the longest side. So that, if we can think about checking, means that we're significantly less likely to make that mistake, which just helps us further down the line. But if we label first, we should avoid it anyway. Okay, so our summary. What we need to do is we need to always label the sides first. So C is opposite the right angle. And then what we want to do is we want to substitute carefully into this and then solve. So there's our summary. Write that down. Make sure it's really clear. They're the key points to take away. And then we're going to move on to the practice. Okay, so practice questions. See if you can do this without your notes. You can check the answers as you go. If you're stuck, you can come back, you can watch the videos, the help, or you can go back over the examples, or you can get in touch. So label the sides of this right angled triangle, A, B and C, and substitute into the formula to find x. So we're always starting. It takes me about 10 seconds to do my labelling, because I got that little shortcut with the C. Okay, so A squared plus B squared equals C squared. So I can work this out like so. Adding them together gives 100. And then square root, 10 centimetres makes sense because it's the longest side. Okay, B, label the sides, substitute into the formula to find x. So again, C, and then A and B don't matter. So this time I have 10 squared plus x squared equals C squared. And because I've labelled and carefully substituted into my formula, then it eliminates a lot of my opportunities to make mistakes. And then square root. Okay, so rounding, 1, 2, 3, round, And that's actually going to push us up to 15.0 centimetres. So 15.0 centimetres, which makes sense because that has to be the longest side. So take care with those ones. Okay, C. A farmer drives his tractor 120 metres east, then 200 metres south. By drawing a diagram, work out the shortest distance from his location to his starting point. So a farmer starts here, he drives 120 metres east, and then 200 metres south. And it says draw a diagram to work out the shortest distance from his location, which is here, to his starting point. Now I actually know this is a right angle because we're going east and then south, and they meet at 90 degrees. So I can use Pythagoras to solve this. So C, A and B, and this is what I'm trying to find because that is the shortest distance back to his starting point. Now remember my formula. So 120 squared plus 200 squared some big numbers here. So we add those together. So C equals square rooting. And then we can round. So 1, 2, 3, and then round. So C equals 233 metres. And that is my answer. Okay, good. So if you found that helpful, there's lots more useful things at www.stutchfield.com. So head on over there if you want something extra to keep up your momentum. Well done.